Here we have the introduction to integer problems. Integer problems most commonly deal with either consecutive even integers or consecutive odd integers. And on occasion we see just the regular consecutive integer problem. I like to use the information that I know in the word problem when I'm declaring my variables. And what I mean by this is if I know that I'm working with an even integer, I like to represent my variables as even integers. An example, if you think of any integer, any number that's a whole number or positive, negative, if you take that number and you multiply it by 2, the result is even. Like a negative 7 times 2 is negative 14. 3 times 2 is 6. 4 times 2 is 8. So any integer that you come up with and you multiply by 2, it generates an even value. And so when I declare for consecutive even integers, most commonly they'll ask for like 3 consecutive even integers or 4 consecutive even integers, I start with the words first, second, third. And then I use the information I know. If it's an even integer, I can start with 2n. Now once you have an even integer like 10, you know that the next even integer is found by simply adding 2. And then you just continue this pattern of adding 2 for every additional integer. So I start with 2n. To find the next even integer, I add 2, so it's 2n plus 2. If I add 2 to this, it would be 2n plus 2, which is simplified as 2n plus 4. That's how I represent even integers. In a similar way, I know that for every even integer you have, the next number is odd. So if they ask for consecutive odd integers, if I add 1 to an even number, 2 plus 1 is 3, that's odd. 4 plus 1 is 5, it's odd. I can take this expression and simply add 1 to it, and then add 2 to each following number to get odd integers. Exactly what I'm talking about. If I have the consecutive odd integers, I start with this 2n plus 1 because that would represent an even plus 1, which is guaranteed to be odd. And then I add 2 to each expression. When I add 2 to this expression, it goes to 2n plus 3. That's an odd number. When I add another 2, 2n plus 5, that would be a third odd number. And if I wanted to continue the pattern, the next would be 2n plus 7, so on and so forth. This has all the qualities of an odd number. And finally, if we're dealing with just regular consecutive integer values, we don't know whether we start with even or odd, and so we try to be as generic as possible. In class, when I talk about the consecutive integers, I start with the first, second, third idea, and I use x plus 1, x plus 2, x plus 3, because we see that this is just a regular progression of integers. For the notes, I did do it a little differently. When I typed them up, I started with x, and then I went x plus 1, x plus 2. So here we actually see two different ways that you could declare variables here. We use the general x, because it's a very generic form, and we're able to generate these numbers, one after the other. For the odd integers, we use the n's, and we go 2n, and then we add odd values, because we know that gets us to odd end results. And for the evens, we start with the 2n and we add even values. So consecutive even integers, we have 2n's, add 2 each time. For odd integers, we have 2n, but we add odd values on the end. And for these generic consecutive integer problems, we go x, x plus 1, x plus 2, or you can go x plus 1, x plus 2, x plus 3, because we see that regular progression, that regular counting progression.